According to the National Electrical Code, specifically NEC 2005, Section 422.13, fixed water heaters with a capacity of less than 120 gallons are classified as continuous loads. This classification has significant implications when determining the demand load for dwelling unit feeders. To properly size the feeder conductors and overcurrent protection, one must account for the continuous nature of the water heater's load. The code mandates that continuous loads be calculated at 125% of their nameplate rating. This requirement is in place to ensure that the electrical system can safely handle the sustained operation of these loads without overheating or causing damage. The question that often arises is whether the 40% derating factor outlined in Section 220.82 of the NEC can be applied to the 125% value of the water heater load, or if the feeder must be rated for the full 125% without any reduction. The correct interpretation is that the 40% derating factor from Section 220.82 can indeed be applied to the 125% value of the water heater load, provided that the conditions specified in 220.82 are met. Section 220.82 provides an optional method for calculating the feeder or service load for a dwelling unit. This section allows for a demand factor of 40% to be applied to the nameplate ratings of 4 or more separately controlled electric space heating, air conditioning, and heat pump loads. The key here is that the water heater, being a continuous load, is first calculated at 125% of its nameplate rating. Then, if the requirements of 220.82 are met, the 40% demand factor can be applied to the total calculated load, which includes the 125% value of the water heater load. It's important to understand that the 125% factor is applied to account for the continuous nature of the water heater load, and the 40% demand factor is applied to recognize that not all loads in a dwelling unit will operate at their maximum rating simultaneously. Let's illustrate this with an example. Assume a water heater has a nameplate rating of 4,500 watts at 240 volts. To determine the continuous load, we first calculate 125% of the nameplate rating. This gives us 1.25 multiplied by 4,500 watts, which equals 5,625 watts. Now let's assume that the dwelling unit also has electric space heating, air conditioning, and other major appliances, and that the conditions of Section 220.82 are met, allowing us to apply the 40% demand factor. To do this, we would include the 5,625 watts in the total load calculation for the dwelling unit, and then apply the 40% demand factor to the total. For example, if the total load before applying the demand factor is 20,000 watts, including the 5,625 watts for the water heater, we would multiply 20,000 watts by 0.4, which equals 8,000 watts. This means that the calculated demand load for the feeder would be 8,000 watts. It's crucial to remember that the 40% demand factor is only applicable if the conditions of Section 220.82 are met, specifically the presence of 4 or more separately controlled electric space heating, air conditioning, and heat pump loads. If these conditions are not met, the feeder must be sized to carry the full 125% of the water heater load without any reduction. In summary, when dealing with water heaters less than 120 gallons, which are considered continuous loads, you must first calculate the load at 125% of the nameplate rating. Then, if the conditions of Section 220.82 are met, you can apply the 40% demand factor to the total calculated load, which includes the 125% value of the water heater load. Always consult the latest edition of the National Electrical Code and local amendments to ensure compliance with all applicable regulations. Furthermore, it is important to consider the voltage drop in the conductors. While the NEC provides guidelines for minimum conductor sizes based on ampacity, it is crucial to calculate the voltage drop to ensure that it does not exceed the recommended limits. Excessive voltage drop can lead to inefficient operation of equipment, overheating of conductors, and premature failure of components. Voltage drop is calculated based on the conductor length, conductor size, conductor material such as copper or aluminum, and the amount of current flowing through the conductor. The NEC provides formulas and tables for calculating voltage drop. It is recommended to use a voltage drop calculator or consult with a qualified electrical engineer to ensure that the voltage drop is within acceptable limits. In addition to voltage drop, it is also important to consider the ambient temperature when selecting conductor sizes. The ampacity of a conductor is based on its ability to dissipate heat. When conductors are installed in high ambient temperatures, their ampacity is reduced. The NEC provides ampacity correction factors for various ambient temperatures. It is essential to apply these correction factors to ensure that the conductors are adequately sized for the operating conditions. Overcurrent protection is another critical aspect of electrical system design. Overcurrent protection devices such as circuit breakers and fuses are designed to protect conductors and equipment from overloads and short circuits. The size of the overcurrent protection device must be coordinated with the ampacity of the conductors. The NEC provides guidelines for selecting the appropriate overcurrent protection device for various applications. It is important to select an overcurrent protection device that is rated to interrupt the available fault current at the installation location. Available fault current is the maximum amount of current that can flow during a short circuit. If the overcurrent protection device is not rated to interrupt the available fault current, it may fail to clear the fault, resulting in damage to equipment and potential hazards. Grounding and bonding are also essential for electrical safety. Grounding provides a lower impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and clear the fault. Bonding connects all non-current carrying metal parts of the electrical system together, creating an equipotential plane. This helps to prevent electric shock hazards. The NEC provides detailed requirements for grounding and bonding. It is important to follow these requirements carefully to ensure electrical safety. Furthermore, it is always recommended to consult with a qualified electrical inspector or engineer to ensure that the electrical installation complies with all applicable codes and standards. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. Always to energize circuits before working on them, and use appropriate personal protective equipment such as gloves and safety glasses. In addition to the specific requirements for water heaters, the NEC also contains general requirements for dwelling unit feeders. These requirements cover topics such as conductor sizing, overcurrent protection, grounding, and bonding. It is important to be familiar with these general requirements as well as the specific requirements for water heaters. The NEC is a complex document, and it is essential to stay up to date with the latest revisions. The NEC is updated every 3 years, and it is important to use the most current edition. Changes to the NEC can affect the design and installation of electrical systems. It is also important to be aware of any local amendments to the NEC. Local jurisdictions may adopt amendments to the NEC to address specific local conditions. These amendments can be more restrictive than the NEC. It is important to comply with both the NEC and any local amendments. Finally, it is important to remember that electrical safety is paramount. Always take the necessary precautions to prevent accidents. If you are not qualified to perform electrical work, hire a licensed electrician. Electricity is a powerful force, and it can be dangerous if not handled properly. A licensed electrician has the training and experience to perform electrical work safely and in accordance with all applicable codes and standards. They can also help you to identify and correct any potential hazards in your electrical system. When selecting an electrician, be sure to check their credentials and references. Ask for proof of insurance and licensing. A reputable electrician will be happy to provide this information. It is also a good idea to get multiple bids before hiring an electrician. This will help you to ensure that you are getting a fair price for the work. Be sure to compare the bids carefully and ask any questions you may have before making a decision. Once you have selected an electrician, be sure to get a written contract that outlines the scope of work, the price, and the payment schedule. This will help to protect you in case of any disputes. During the electrical work, be sure to keep children and pets away from the work area. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. After the electrical work is completed, be sure to inspect the work carefully. Make sure that everything is working properly and that there are no exposed wires or other hazards. If you have any concerns, contact the electrician immediately. Properly installed and maintained electrical systems are essential for the safety and comfort of your home. By following the guidelines in the NEC and consulting with qualified professionals, you can help to ensure that your electrical system is safe and reliable. Remember to always prioritize safety and to never attempt electrical work unless you are qualified to do so. Engaging a licensed electrician is a worthwhile investment in the safety and longevity of your electrical infrastructure.